In this video, I've taken 4 questions, and all these 4 questions have they can be solved in a very similar way. In all these questions, you'll find something common, that there will be some fixed distance given. Some fixed distance will be given here, and then there will be speed given, which is less or more. Like that means the first speed will be the usual speed, and then the other will be usual plus something or usual minus something. As you can see that in all these cases, you will have some this speed more or less than the previous one. All right. Now, you can also figure out that in something else will be there, that is difference in time. That is also, you'll see that there is a difference in time will be given. So we'll be using this relation to find the difference of the time. So all these 4 questions have to be solved in the same manner. And let's say if I begin with the first question. So for that, let's say if I minimize the other part, I'm starting with the first here. Right. So if you see in this question, what we have been given that, if I read it, it says that here the fixed speed is given x. A train is at a has to travel a distance of 480 kilometer at a uniform speed. It says if the speed is 8 kilometer less, then it would take 3 hours more time for 3 hours more to cover the same distance, and we need to find the speed of the train. Now, as I said, we'll have some fixed speed, which I have taken as x. The new speed will be something more or less, but over here it is 8 kilometer less. So I'll say that the new speed is x minus 8 kilometer per hour. Now we can use this relation, that is distance is equal to time is equal to distance upon speed. We can find the usual time. So usual time is equal to distance upon speed. Distance is fixed here, which is 480 upon the speed, which is x as the usual case. And the new time will be same relation, distance upon speed, and the speed is x minus 8. Now from this equation, I've taken this as t1 and this as t2. So we can see that, as you know, that to cover the same distance, the smaller the speed, the greater the time needed. So from here, we will say that T1 is greater than, right? This is, I have taken, both are T1. Let's say if I mark it, this is T2. And I can say this is T2. T2 is greater than T1. And the difference in time, that is T1 minus T2, we can figure out from here is 3 hours. So I'll write T1 minus T2 is equal to 3. I can replace T1 with its value, that is it's T2, T2 minus T1, although I said T2 minus T1 only. T2 minus T1 is 3 here, T2 which is 480 by x minus 8 minus T1 which is 480 over x is equal to 3. Now after that, we can take 480 as common. Let's see if I do from here. So I can see that we can take 480 as common. This way we'll reduce the calculation. It becomes 1 over x minus 8 minus 1 over x, that is equal to 3. Now next I'm going to transpose this to the other side. So this is 3 over 480. And if I take LCM, it's going to be x multiplied by x minus 8. This LCM divided by x minus 8 is x, and 1 multiplied by x is this. LCM divided by x is x minus 8. That multiplied by minus 1, right? We have a minus 1, so it will become minus x plus 8. Need to understand here, right, that we are multiplying minus 1 with this. Okay, we can figure out that here these get cancelled. And further, I can see that this also can be reduced. This is 1 time, and 480 is what? 316 times. Now, if I simplify it further, if I'm doing cross multiplication, this is x square minus 8x multiplied by 1. So this is x square minus 8x. And on the other side, this is you have to multiply 16 into 8. So 16 into 8 is 128. So it is 128 on the right hand side, and there is 10. Now we framed a quadratic equation. We can further minimize this step by transposing 1280 to the left hand side. So it will become minus. So what I did here, let's understand. I'm transposing 1280 to the left hand side, then it will become minus 1280 equal to 0. So we frame this quadratic equation, and then we are going to factorize it to obtain the solution of this equation. To solve this equation, I'm going to factorize the middle term. The middle term splitting here is what? 1280. If I factorize, let's say by 2, it is coming as 640. With 2 again, it is 320. We need to obtain 8. With 2 again, it is 160. With 2, it is 80. And with 2, it is 40. What you can say, this is 32. This is 32 and 40. 32 and 40 will give you, the difference will give you 8. 32 and 40. So this is what I'm going to do. I'm splitting this 4 as this 8x. I'm splitting this minus 8x, and we'll write as minus 40x plus 32x minus 1280 equals 0. So what is common between first two terms? Clearly it is x. So it is x minus 40. The common between the last two terms is 32. And again, it's x minus 40 equals 0. Now, on taking x minus 40 as common, we'll get x minus 40 plus x plus 32 equals 0. Equating this with 0, we'll get x is equal to 40. And equating this with 0, we'll say x is equal to minus 32. As you know that the speed cannot be negative, so we'll declare x is equal to 40 as the usual speed. Now we have done the first part. Let's do the other part here. For that, I'll erase this. First question is done. Taking the second question here. In the second question, as you can see, it like previous, we have a fixed distance. We have a usual speed being x, the new speed being given x plus 5. So I'll write this as, it is more, right? That's why. Is it more? Yeah, it is more. As you can see, it is more. And therefore, we can find the time using this relation. Time is equal to distance upon speed. Distance is 360. The speed is x. In the second case, distance remains the same. The speed is x plus 5. Now, this time you will figure out that this time is, that is T1 is greater than T2. Reason being, if you cover the same distance, the smaller the speed, the longer the time takes. So I can say from here that is T1 minus T2. T1 minus T2 is equal to the difference in time, which is 1 hour here. Now I can replace T1 with its value, that is 360 over x minus the other, which is 360 over x plus 5, and which is equal to difference in time, that is 1 hour. Like the previous case, here also I will take 360 as common. So it is 1 over x minus 1 over x plus 5, that is equal to 1. Now I can transpose 1 to 360 to the other side. While in doing so, it will become 1 over 360. And taking LCM on the left-hand side, this is x multiplied by x plus 5. Now the LCM divided by x is x plus 5, which multiplied by 1 is this, and the next is minus x. Here too we get x and x get cancelled. Now I'll do cross multiplication. So this is x squared plus 5x multiplied by 1 will give you x squared plus 5x. And 360, 5 multiplied by 360 is 1800. That's it. Yeah, it's 1800 on the right hand side. I'll write minus 1800 on the left hand side equals 0. Now we have obtained this quadratic equation. Once we have obtained this, now we have to factorize it. Now for doing so, what I'm going to do, I'm factorizing 1800 to show the working. This is 900 by 2 times, with 2 again, this is 450. With 3 again, it is 150. Oh, I can continue to divide it by 2 until the 2 get exhausted. So it's 2 to 5. Now with 3, it is 75 times. Keeping in mind, we have to get 5. So this is 3, 25 times, and 5, 5 times, 5, 1 times. Well, I figured out that this is how much? This is 8. And let's say I took 1, 5. 8 and 5 is how much? 40. So this is 40 and this is 45. So 40 plus 40 and 45 difference is 5x. So we can factorize like this. This is x squared, and I'm splitting this middle term, that is 5x, right? I'm splitting this 5x here. 5x can be split as 40x, 45x, 45 minus 45x minus 40x, and then minus 1800 equals 0. When I take x common, I'll get x plus 45. And when I take minus 40 common, I'll again get x plus 45 equals 0. Further, I can see that we have x plus 45 or x minus 40 equals 0. So let's erase this part. Now, equating this with 0, we get x is equal to minus 45. Equating this with 0, we get x is equal to 40. Clearly, distance speed cannot be negative, so we'll declare x is equal to 40 is the speed. We have done the second question also. Now we'll just move to the next. So let's erase this. And now we'll do the next, that is question number 3 by the order. Now, in this question, like the previous two questions, we have the fixed distance as 130. We'll consider the fixed usual speed bx, and the new speed is, this is 18 kilometer more. So I can say that the new speed will be x plus 18, x plus 11, not 18, x plus 11. So using this relation, we can say that the distance, the usual speed is equal to distance upon time. Distance is 120 divided by time, and the time is, no, sorry, distance upon speed, right? So this is speed is what x in the usual case. In the next case, it is 132 over x plus 5. Here also I can see that smaller the speed, greater the time taken. So we can conclude here that T1 is bigger here. So I'll say that T1 minus T2 is difference in time, and difference in time is 1 hour is equal to 1. So this is 132 over x from here. I'm taking from here, minus T2, which is 132 over x plus 5 equals 1. Now I'll take LCM here and we'll transpose 132 over the other side. The LCM comes out to be x multiplied by x plus 5. This will give you 1 here. That is because we have taken 132 common. So on the other side is 1 only. So it is x plus 5 and x multiplied by 1, which is minus 1 in this case. Now, if I do cross multiplication, this is x squared plus 5. When multiplied by 1 is x squared plus 5. And this 132 multiplied by 5 will give you 132 half, right? So it's 132 multiplied by 5 is 6600. So this is other side, it is 660. So it is 132 multiplied by 5. Now I'm writing this in the standard form. So it's going to be x square plus 5x minus 660. We did a mistake, and I copied this 5 as wrong. It's not 5 over here. It's not 5, it's 11. Right. As for you can see, this is x plus 11, right? It is more. So this is x plus 11 here. So if I take 32 common, and if I transpose it, we are going to get this. And if I take LCM, it's going to be x multiplied by x plus 11, and this is going to be x plus 11 minus x. This get cancelled, is equal to 1 over 132. And I'm doing cross multiplication. This is x squared plus 11x multiplied by 1 is x squared plus 11x. And this is 11 multiplied by 132. So when 132 multiplied by 11, we get 132 multiplied by 11 should give you 1452. So now writing them in the standard form, this is x squared plus 11x minus 1450. Now for obtaining this, you can use an idea. You know that you have obtained 1450 by multiplying 11 with 132. That means 132 into 11. Further, if you split this 132, you should know that this is 12 into 11, and this 11 being copied. I can reduce it further as 3 into 4, and others 2 11s are copied. Now I can see that if I club this 3 and say 11 here, I'm getting 33. So there is a 33 from here and 44 from here. So 44 minus 33 is 11. That's what I'm going to do here. I'll use middle term splitting. 11x can be obtained as 44x minus 33x. And then this is minus 1450 equals 0. Taking x common, we'll get x plus 44. And minus 33 common is x plus 44 equals 0. So finally, it is x plus 44 and x minus 33 equals 0. Equating this with 0, we are getting x is equal to minus 4. That is not possible, as you know that. We'll say that this is not possible as the speed cannot be negative. And finally, we'll declare that the usual speed is 33 kilometer per hour. That's how this question is done. Now we are left with one more, and that is slightly different from the remaining 3 parts that we did. Let's figure out what is there in the final part of this. Now we erase this and maximize the size of this. Yeah, big enough to be read. Right. In this case, so we can observe that we have this fixed distance as 24, and but then you have to read this because the slightly difference, as I said, that here the motor boat moves with a speed of 18 kilometer per hour in still water. That means in the when the water is stagnant, that is when it is not flowing, is what? Still water. Then it takes 1 hour more to cover this 24 kilometer upstream. Upstream is what? Against the stream. And then to return, that is downstream, that is towards the stream to the same spot. We have to find the speed of the stream. So what I can say that, let's say if I make like this. So assume AB, the water is flowing. Assume this is flowing in this direction. Then B to A is considered as downstream and A to B should be considered as upstream. Right. And here we know the speed of the boat, right, in still water. So we do not know the speed of the stream, which I'm going to consider the speed of the stream. Let's say the speed of stream is X kilometer per hour. So what you can see that the speed while going against the stream, right, speed upstream, we say this speed upstream is going to be, as you know that against the speed, that is the speed of the boat minus the speed of the boat is 18. This is 18 minus. This is important to remember that when you travel against the speed, your speed will be, that is the resultant speed will be the speed of the boat minus the speed of the stream, because the stream, that is the water, will tend to move you in the backward direction. And similarly, if you get the speed in downstream, it is that is towards this stream. So the speed in the resultant speed is equal to speed of the boat plus speed of the water. So we got these two speed here. We'll be discarding this as of now. This is not needed. Now we'll be finding the time. Here onwards, we'll be doing the same manner, finding the time, which is distance upon speed. Let's say if I find time in two cases, I'm considering the first one, that is the time here, that is say I write T1, which is say upstream. Time is equal to distance upon speed. Well, distance is mentioned, it is 24. So this is 24 over, it is upstream, and upstream speed is 18 minus x. Now, if I figure out what is T2 here, that is downstream here, and downstream speed, well, applying the same formula, distance is equal, time is equal to distance upon speed, we can see that distance is 24 and speed is 18 plus x. Now, you know that here the speed is smaller. To cover the same distance, the smaller the speed, the greater the time taken. So we can figure out that here time 1 is greater. So T1 is greater. So T1 minus T2, that is the difference in time. And I can see difference in time is 1 hour. This is 1. So T1, which is, I will plug in T1 from here, which is 24 over 18 minus x minus 24 over 18 plus x is equal to 1. Same as the previous last three cases we are doing, we are transposing 24 to the other side. So this will give you 1 over 18 minus x minus 1 over 18 plus x. Now to simplify it further, we are going to take LCM. So LCM is going to be the product of these two, that is, it is 18 minus x and 18 plus x. So on the numerator, you'll get 18 plus x and minus of this, that is minus 18 plus x is equal to 1 over 24. I can see this get cancelled. We are left in the numerator as 2x, denominator 18 square is 324 minus x square is equal to 1 over 24. Now we'll do cross multiplication. So I can say that 24 into 2, that is 48x. And on the other side, this is 324 minus x square. Writing in the standard form. So first is x square plus 48x and minus 324 is equal to 0. Now we have to do middle term splitting. You may do by other method of, that is quadratic formula. So if I do factorization, we have to obtain 48 from 324. 324 is nothing but 18 into 18, right? 18 into 18. So I can split this as, I want to split as 6 into 3. Let's see, this is also 6 into 3. And what will it? 48. Let's do by the normal method of factorization. I'm factorizing 3 to 4. With 2, it is going to be 162. With 2 again, this is 81. With 3, it's 27. With 3, it is 9. With 3, it is 3 and 3 ones. So I can see that this is 339, and to clubbing this, right, these here. So this is 27 into 2, that is 54. And then 2 into 3, that is 6. Yeah, their difference is 48. So that's what I'm going to do. I'm splitting this positive 48 here. And I can write this as x squared plus 54x minus 6x minus 324 equals 0. So that's very clear from here that how I have split 48. Now, if I see common between the first two terms, it is x. So it is x plus 54. And if I take minus 6 common, it is x plus 54 equals 0. So finally, it is x minus 6 and x plus 54 equals 0. So finally, x is equal to 6. Equating this with 0, we are getting minus 54, not possible. So we can now say that x is 6 here. And that's what we have assumed. We have assumed the speed of this stream as x. So we can say it is 6 kilometers per hour. So this is how we did all 4 questions.